Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at scatterplots. So scatterplots are used to display a certain type of data in maths. That data we're looking at is bivariate. So you use scatterplot when you have two different numerical variables. What does that mean? Let's look at an example of a scatterplot. All scatterplots look like this. They basically have a quadrant of the Cartesian plane and lots of dots. Each of these dots represents like one observation. It is associated with two variables. I just called them V1 and V2. A variable in statistics is something that can be measured, something that changes from person to person. So this example here is a scatterplot of height versus weight. Height is a variable because the height varies from person to person. Weight is a variable. It varies from person to person. So each of these dots here is associated with two numbers. The height, let's say the height's along here. The height is this number here, and the weight, which is this number here. So how far you go along for each person is determined by their height. How far you go up is determined by their weight. So when we have scatterplots, we want to look at the relationship between the two variables. So here we're looking at the relationship between height and weight. We also want to state whether the relationship we're talking about is strong, moderate, weak, non-existent, whatever. What do we mean by this? So when we're talking about the strength of a relationship, we're sort of asking how closely does the data fall in a straight line? If I were to draw a line that goes in the same direction as most of the data, it'll look like that. So does this line approximate the data well? Does this data basically fall in a straight line? Well, here you can see it sort of falls in a straight line, but it's nowhere near perfect. So we call that a moderate relationship. The line does just an okay job of representing the data. So the relationship between the data in this scatterplot is positive. That means as one variable increases, the other tends to increase. As you go to the right, you tend to go up. The reason we call it positive is because this line has a positive gradient. So what does this mean in like layman's terms? What does it mean that the relationship between height and weight is positive? It means that as height tends to increase, weight tends to increase. In other words, taller people tend to weigh more. I'm not saying that taller people always weigh more. Of course, like a small, muscly guy might weigh more than a tall, skinny dude. That's of course possible. It isn't saying that taller people are always heavier. It's just saying that as your height increases, so too your weight tends to increase. And you know that. As you became taller, as you grew as a kid, you tended to weigh more. That's what positive relationship means. So over here we have a negative relationship, and that's the opposite. As one variable goes up, the other goes down. As we're going across, one variable's increasing, the other's going down. We're sort of, as we go to the right, we're going down. If I were to draw a line that goes through the data points here, that line leans to the left and has a negative gradient. So what we're saying here, negative means as one variable increases, the other decreases. So we're increasing and going down. So an example of two variables that might be negatively related, hot chocolate sales and temperature. As one increases, the other tends to go down. As the temperature goes up, hot chocolate sales tend to go down. You tend to sell more hot chocolate when the temperature's lower, less hot chocolate when the temperature is higher. So I've drawn a scatterplot that shows a strong relationship. The reason that this relationship is strong is the data very closely falls in a straight line. It's not perfect. The points here don't fall exactly in a straight line, but it's very close. That's what we mean by a strong relationship. So when you're asked to look at a scatterplot, you'll be asked to comment on the strength, how closely does the data fall in a straight line, and you'll also be asked whether the relationship is positive or negative. So there is, of course, the possibility the data doesn't lie in a straight line at all. What that means is, as one variable goes up, the other sort of doesn't go up or down. You can see here, as we go across, sometimes the other variable goes up, sometimes it goes down. If I go across here, we could go up or down. If I go from here, go across, we could go up or down. This is a non-linear relationship. This relationship is neither positive nor negative. It's basically showing two variables that don't have anything to do with each other. So an example might be IQ and shoe size. They have nothing to do with each other. As your shoe size goes up, it doesn't really do anything with your IQ. People with a higher IQ don't necessarily have a larger or a smaller shoe size. These two have nothing to do with each other. So let's look at an example now where we construct our own scatter plots. So here I've got two variables for 7 different students. So each student's a different observation. One variable is their English mark, one variable is their SOS mark. These two things are variables because they're measured. They are different from person to person. So we can only use scatter plots when the data is numerical. So numerical data means that it would be given in numbers. So if you were to ask people their English mark, they would give you a number. If you were to ask them their English grade, A, B, C, D, or E, they wouldn't give you a number, and so the grade is not numerical, whereas the mark is. We couldn't use a scatter plot to compare English and SOS grades, A, B, C, D, and E, because they're not numbers, they're not numerical. So here we have 7 students, so our scatter plot will have 7 dots, each dot representing a student. So this first student scored 16 in English and 8 in SOS. So for E for English, S for SOS, we go across 16 for English and up to 8 for SOS. And we do the same for each other score. Second student, English score was 8, SOS mark was 3, so we get 8 and 3 would be about there. So now I've plotted each of the 7 points, just like plotting points in the Cartesian plane. This is our scatter plot. So we can use it to answer questions about the relationship between these two. So firstly, is the relationship strong? Well, that's a bit subjective. You'd say, yeah, it's reasonably strong. A straight line does a good job of capturing the data. So like if we draw a straight line there, it picks up most of the data. Most of the data is close to the line rather than far away, so it does a reasonably good job. So it's a reasonably strong relationship. Whether you said it's a strong or moderate relationship, you could argue both of those. So that's not so clear, but what is clear is whether the relationship is positive or negative. We can see clearly that this line leans to the right, has a positive gradient. As we're going to the right, we tend to go up. What this means is the relationship between English and SOS is a positive relationship. As a student's English mark increases, so too their SOS mark tends to increase. Again, it's not foolproof, it's not perfect. It's not saying that people who did well in English will definitely do well in SOS. There were some exceptions to this rule. This person here, for example, scored 10 out of 20 in English, scored one of the lower English marks, but got the highest SOS mark. Over here, the opposite is true. Students over here scored one of the lower SOS marks, but a higher English mark. So it's not a perfect relationship. It's just saying that as the English mark tends to increase, the SOS mark also tends to increase. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.